Parallelism is another area that you can look at for performance of your data pump jobs. And indeed, it's just about the only user accessible knob that you can use to change the performance of a data pump job. Parallelism that we recommend is up to 2 times the number of physical CPU cores on your system. Now, you might want to balance that with other workloads that are on your system if you don't want data pump to consume all of the system resources, because data pump was designed to use all the resources that you're willing to throw at it. So if you have other workloads on the system, you might constrain your data pump job and say, well, we have 32 CPUs, but we're going to do an export with parallel 4. But if all you're doing is migrating a large database and you've got 128 physical cores on the system, then yes, you could do an export with parallel 256. We have customers who do that, and it's very efficient. But let's get back to this concept of physical CPU cores, because it's not the same as CPU count. That parameter that you can query out of Oracle, CPU underscore count, is actually the number of physical cores times the hyperthreading factor for that CPU architecture. So on an x86 system, which is generally two-way hyperthreaded, CPU count will be 2 times the number of physical CPU cores. But on other CPUs like PowerPC, like Spark, you may find as many as 8-way hyperthreading. So you can't depend on CPU count in those cases. You actually have to know how many physical cores there are on the system, because generally system I/O is balanced to physical cores, not to hyperthreading. And then as a side note, in Oracle Cloud terms, an OCPU is 1 hyperthread of an x86 core for the x86 architecture. So for, say, a 4 OCPU shape, you should be comfortable going to parallel 4 with data pump. Now, when it comes to parallelism for exports versus imports, it's important to note that multiple log files are absolutely necessary if you're going to use parallel on the export. So if you're going to export with any degree of parallelism greater than 1, then use the wildcard that would enable us to create multiple log files, because that way each individual parallel process that's writing data to a file gets its own file to write to, and they won't be blocking each other for file access. On import, however, the degree of parallelism used to export a database has nothing to do with the degree of parallelism you can use to import effectively. You could have a massive database that was exported with just one huge data file, and then you could go parallel 32 on the import and have 32 workers all loading in parallel out of that single file, because readers do not block readers to on-disk files. So it doesn't matter what you exported with, you can import with whatever would be most efficient on your target system.